For the x-intercept, y is equal to 0. That means 0 equals negative ln of x plus 2. So now you say, okay, e to the 0 is how much?
Oh,
e to the 0 equals x plus 2.
X plus 2.
X equals e to the 0 minus 2.
Oh no, the negative will cancel out here. Yeah. Here you can just divide a negative out, and the negative just goes away. You take an e of, but you raise both as an exponential of e. So here we have 1 is equal to x plus 2, so x equals negative 1. Okay, so the x-intercept is negative 1 comma 0. The y-intercept is when x equals 0, so it's negative ln of 0 plus 2, which is negative ln of 2. So it's 0 comma negative ln of 2. Okay, so I will specify, how you need to give your answer. If I haven't specified decimal or not decimal, then it's up to you. Okay, for exponential functions, the domain is all reals. For logarithmic functions, the range is all reals. That means the domain is not, right? So the vertical asymptote here was at negative 2. Okay, so this starts at negative 2 and goes to the right side. So it's negative 2 to infinity.
Oh, why isn't it negative infinity because you have a negative ln?
Okay, so what does a negative ln do? What does negative do for a function? What does it do? It flips it horizontally, or vertically. So it wouldn't go to the other side, okay? Not to the left. When you have a negative in front of a function, it is a vertical reflection. Yes. If you have, okay, so that's a horizontal. Oh my God. Okay. All right, I need to. So here, this is my domain and this is my range. To graph this, we're going to pick points, right? Do you remember how we were doing this before? Yeah. Right? So we pick points. Okay, we already have 2 points here. The x-intercept is negative 1 comma 0. The y-intercept is 0 comma negative ln of 2 here. Right? And it's going to go down to the right. And it follows an asymptote on this side. Okay? All right, so here I have a couple of evaluating problems. So the actual test is not as long as the practice test. This is 23 problems long. There are 15, I believe, on the actual test. But I just like to put a little extra in here. And actually one of them got duplicated, 6 and 7, so we'll take those out. Okay, so here we have log base 3. And what's this? This is 3 to the negative 3. Okay, so this stuff I know you've done before. And here we have log base 4, 4 to the negative half. So that just simplifies to negative 3 plus negative 2.
I don't understand how that has a negative half.
Oh, positive, sorry. So it's negative 3 plus 2, which is minus 1. The next one, it's 2 ln of e to the power of 0.75. So this is 2 times 0.75 minus 2 times 1. Well, remember the 0.75 comes down? So it's 0.75 times 2. So that's 1.5 minus 2 is negative 0.5. The base here is 10, meaning this is log 10. And what's 0.01? It's 1 over 100. So this is log base 10, 10 to the negative 2. So the answer is just negative 2. If you can see it, then that's totally fine. Okay?
If we just plug it into our calculator.
Right, so on the test you will not have ones that you can plug into the calculator. But if there is one, and you just plug it into the calculator and give the answer without any work, I'm not going to give you full credit. Okay? All right, these are duplicates, so this goes away, and it's just 3.1. Okay?
How do we show work for that? We just cross it out, right?
Yeah, just cross it out.
Also 3.1.
Right. So this I mistakenly duplicated. All right, so here, first the power will come down. And you have 4 root y over cube root of x. And now we're going to expand the log. So it's 3 log base 2, 4 root y minus, I have a bracket here, minus log base 2 cube root of x. Okay?
Can't you also just like distribute the 3 into the log, like with all of them, like 4 plus?
Well, we're not done yet here. Okay, we're not done yet here because what is this? This is square root of y, but it's y to the power of half. So it's 3 to the power of log base 2 of 4 plus log base 2 y to the half minus log base 2 x to the third. Okay? And you can continue some more, because what's log base 2 to the 4? Log base 2, 2 squared, plus half log base 2 of y minus a third log base 2 of x. And now finally, the final answer is 3 times, here we have 2 plus half log base 2 of y minus a third log of x. Okay? Yeah. Yeah.
I'm kind of confused with the y to the 1/2.
Okay.
How'd you get there?
Well, it was square root of y here.
Oh yeah, square root of y is part of it. Okay.
Right.
Do we always have to separate it because it's multiplied?
Always. All right. This next one needs to be condensed. Yes.
How come you not log base 2 of 4?
Well, it's 4 times root y. Huh?
Yeah, property.
You have to split the 4 and the y because it's 4 times root y. So however many elements there are, that's how many logarithms you want. Okay? All right, so here we have, we're going to have a fraction. You have ln of x times x squared minus 100, and whatever has a negative goes downstairs, right? So 3 times x minus 10. And here we need to simplify. X minus 10, x plus 10, 3 times x minus 10. So we have ln of x plus 10. I'm sorry, ln of x plus 10 over 3. Okay? You can put parentheses around it. It's probably a good idea. Here is another one we need to condense. You want a drink of water? Yes. So this goes up, becomes an exponent. Yes.
Why is it 3 times x minus 10 on the bottom, not 3 over x minus 10 on the bottom?
Right, you're subtract. Okay, so you have one main fraction. Okay. Whatever has a plus sign goes on top of the fraction. Whatever has a minus sign goes on the bottom of the fraction.
No, but can't you like do it like individual x?
Right, but it's not 3. If here in the bottom I had 3 divided by x minus 10, then where would the x minus 10 end up? It would be,
No, but looking at not what we wrote, but like the problem.
Yeah.
It's like ln of 3 minus.
right. Right, so another way of looking at it is, this is minus plus like this.
Because it's 2
Right?
x's means they're both
So now it's minus. Do you see how when you factor out a minus, this becomes a plus? You don't have to factor out, but like when you do factor out, it's clear to see that the 3 and the x minus 10 need to be multiplied, right? Do you see what I mean? And they're both being multiplied and they're both in the denominator. Do you see what I mean? But the quick way is, like I was saying the other day, the way I look at it is, okay, whatever has a minus sign just immediately goes in the denominator. So you have one fraction, not complex fractions. All right, here it's going to be ln of 2x plus y over x minus y to the power of 1/3, which then you do a cube root, so it'll be ln of 2x plus y over cube root of x minus y, right, all in the ln.
That's the final one.
You done? You don't have to, it just makes it look cleaner, I guess. Okay?
Oh,
You don't have to. Right, that's fine. Yes.
We answer it the first way you put it. What you want.
Yes. You have to write it as a cube root. Here we have some equations. And the first one needs to be condensed before we can solve it. So it's log base 4, x times x plus 2 equals log of 35. Yeah? Then what? So x times x plus 2 equals 35. X squared plus 2x minus 35 equals 0. And we can solve this one, factor, x plus 7, x minus 5. So now I get x is equal to 7, x is equal to negative 5. Clearly, though, the negative 5 does not work. Because if I put negative 5 in here,
You have a log.
I have a log of a negative number, which never works. Okay, Brittany.
Why is it negative
Oh,
5
it should be,
and 7?
it should be negative 7 and 5.
No, positive 7 and negative 5 because I need a positive 2 here.
The,
Then the answer would be negative 7.
The 0 switches. Yeah.
Oh. Oh, wait a minute. Yeah, it does make sense. I just found a mistake somewhere else.
It's negative 7.
Right, so negative 7 and positive 5.
Yeah.
And so that doesn't work. That means it's just x equals 5. All right, so I need to fix that one. Okay. The next one, we have a quadratic form. So rather than x and x, we have e to the x and e to the x. And the rest we need to multiply to 2 and add to -3. So it's -2 minus 1. That means e to the x minus 2 equals 0. E to the x equals 2. And x is equal to ln of 2. E to the x equals 1. X equals ln of 1, which is how much? 0. So the answer is x equals 0 and ln of 2. If you write down ln of 1 as your final answer, points off. Yeah. Okay?
Wait, we can't leave our form and our answer in like U form?
No. Because x, you're solving for x, not e to the x. Right?
Right. Okay, yeah.
All right, here we want to take the ln of both sides. So the procedure for all of these types of problems is the same. It's just a lot of algebra. The negative 4x minus 1 comes down.
We can log them too, right?
I prefer ln. And I've said here to leave your answer in terms of natural logarithms, right? That means ln, okay? No, log is not a natural logarithm. So I've said natural logarithm, which is ln. Log is just a simple logarithm. Log base 10 is the common logarithm. The natural logarithm is just one thing, ln. That's it, okay? All right, so here we distribute the ln's, and you get negative 4x ln of 2 minus ln of 2 equals 2x ln of 3 minus 3 ln of 3. Now collecting the x's, we get negative 4x ln of 2 minus 2x ln of 2 equals ln of 2 minus 3 ln of 3. Okay? I'm going to factor out a what here? A negative 2x, which gives me what? ln of 2 minus ln of 3. This should be ln of 3.
What do you do with the
Equals,
2 from the 4? Isn't it 2 minus 2 ln 2?
oh yes, so 2 ln of 2 minus ln of 3 equals ln of 2 minus 3 ln of 3. Negative 2x equals ln of 2 minus 3 ln of 3 over 2 ln of 2 minus ln of 3. All right, so let's just simplify this before I divide by 2. Here I have ln of 2 over 27 right, because the 3 comes up and becomes an exponent. And on the bottom, I have ln of 4 over 3. And this is equal to negative 2x, remember? Negative 2x equals this. So then x is equal to ln of 2 over 27 over negative 2 ln of 4 over 3. No, absolutely not. Okay?
So when you're
You can't cross out the ln. So like ln of 2 over ln of 3 is not 2 over 3.
when you divide by 2, you just multiply the bottom by -2. When you're doing, yeah.
Say that again?
When you divide by 2, you just multiply the bottom by -2, right?
Yes. Yes.
Ln and log are the same thing, like dual base and compound, like ln is a natural logarithm of 1.
Okay. So log base e is called the natural logarithm because it's sort of like the most natural state for the logarithm to be in. Okay? So that one case where log's base is e, we call it the natural logarithm. It's like the Zen logarithm.
So in what way in this problem does this make sense? There's no ease in this problem.
Right. But, okay, so you can solve this using log or ln. I'm saying to solve it by ln.
But the numbers cancel.
Yes. Because instead of you taking like log base 2 of everything, I'm saying take log base e, which means ln.
Wait,
Yeah.
when you take out a -2,
Yeah, just stick with ln. You'll be fine. All right, so here, okay, so this is e to the root x plus minus 5. And you notice this is e to the 7, right? If you take the reciprocal. And now, that means root x minus 5 equals 7 because the bases are the same. When you take a square, when you square both sides, x minus 5 equals 49. X equals 49 plus 5, which is 54. Okay, so that's another fun one. All right. In this case, we have a compound interest problem. So it says Mr. Smith invested a sum of money in an account that pays 5% interest compounded monthly. Whoa. And then it says, oh, I left the, yeah, I missed polynomial, and then I had switched it. So it's the same person. We'll leave it as Mr. Smith. As opposed to Miss Polynomial. If they made the investment on January 1, 2000, and the account was worth $25,000 on January 1, 2010, what was the original amount in the account? Okay, so what we have here is R is 0.05. The fact that it's compounded monthly means N equals 12. T is 10. A is 25,000. So what I have is P. What I need to find is P. So A is P. Okay. So 25,000 is P. 1 plus 0.05 over 12 to the power of 12 times 10. P times all of this will become 1.647. So when you divide, the principal is $15,179.03.
that's an awfully specific amount to invest.
Yes.
They're like, I have this $15,179.03.
All right, so if $1,000 is deposited in a savings account providing an annual interest rate of 5.6%, so R is 0.056, compounded quarterly, N is equal to 4. How long will it take for the account to be worth $1,500? So this time I want T, right? P is 1,000 and A is 1,500 and we want T. So how do we do this one? 1,500 is equal to 1,000, 1 plus R over N to the power of NT, 4T. All right, so we divide, this is 1.5 equals, let's see, I can simplify this one. What would we get when we simplify this one here? So 1 plus 0.056 over 4. 1.014 to the power of 4t. Now this we need to simplify by ln's, right? So ln of 1.5 is equal to ln of 1.014 to the power of 4t. So ln of 1.5 equals 4t ln of 1.014. So we're going to divide now by 4 ln of 1.014. That gives us ln of All right, so T is 7.29 years. Okay. In 2000, the rabbit population in a certain area was 1,000. The number of rabbits increases exponentially at a rate of 3% per year. Predict the rabbit population in 2020.
So R is 0.03.
Right. Okay, as a rule, A equals P e to the RT is just for interest, just for bank accounts, right? Because what are it's principal and rate and time, right? So that's just for bank account notation. For this one, I know like it's the same exact formula, but different lettering. But it just sounds so odd to use, that for this. So it's y equals y naught e to the kt. Okay?
You would take off if we just do it.
I might. Yeah. Yeah. So, y equals y naught, which is 1,000, e to the 0.03t, and the number, so you get 1,822.1188, but we're not talking about 0.11 rabbits, right? So it's 1,182 rabbits.
No, it's 2,800.
Oh, t is equal to 20, yes.
It's 2,800.
No.
Does the
You
original-
no.
Oh,
You
that's
do not
the
add
total.
this. You do not add this to the original amount. This is everything all together. Yes.
You read it wrong on the line. It's 1,822, not 1.
Oh, 1,822. I got confused with the 1188 there. So 1822. All right. So approximately that many rabbits. Yes. You plug it into the calculator. So it's 1,000 times e to the power of 0.03 times 20. All right, let me try to finish this. Yes.
If it's not exponential growth and it's the opposite decay, are we supposed
Then
to look,
k would be negative.
yeah, and are we supposed to look for why not?
No, the only difference would be that
K is negative.
you would say negative 0.03 instead of positive 0.03. Okay, so here I've told you that you have log of x and h of x, and you want to know how the two are related. Well, you see that they're displaced by 3, right? So it's moved 3 units down, meaning h of x is log of x minus 3. Use the parent graph of f of x equals ln of x to predict the equation of g of x. So what does ln of x look like? I haven't drawn it for you here, right? But you know what ln of x looks like. It touches at
0, 1.
1 and 0. Okay? That's what ln of x looks like. So the one you're given has been it's reflected, right? That means that g of x is first of all negative ln of x. But what else has happened? It moved how much? 1, 2 spaces. So it's negative ln of x minus 2 in parentheses. Okay? Okay, so true or false, and if false, you have to write the correct statement. So this is false.
The bottom is 1, right?
Okay?
Wait, why is that?
Because this isn't completely...
But isn't that the definition of log?
No, because when you combine those, there's only one log. It's log 49/7, not log
Mhm.
49
Wait.
Right. So this is just division of 2 logs. Okay? You can't bring this over this way. So if you wanted to condense this, this would be equal to log 749 over 7. Right? Not this. Okay?
So what do we have to write?
So you would say log 749 minus log 77 equals log 7 49 over 7.
What does the log be 749 after the 7 actually?
Is it log 7, 7?
Isn't it that?
Huh?
I'm confused. Then what would it equal?
Huh?
What would it equal? What do you cross out?
The part you crossed out, so you could also do that, right? You could also say, okay, so take that one. What would that equal? That would equal log 7 to the power of 7 squared, so it's 2 over 1, right? So you could also write that. All right. Yes.
Isn't it log 7 to the 7th 1? 1. Yeah. Isn't it 1? So can't you just cross that out?
Right. So it becomes 2.
Oh, okay. Sorry.
Okay, so this one, it would be log bx cubed plus log b y cubed. Okay? Which is what?
No.
Yeah, 'cause you distribute.
It's true.
Is it true or false?
Too many choices.
That's not that. That's not the same thing.
No,
They
because
just
the
brought
x
it
cubed
to the left.
times y cubed. Is that what it's?
Yes. So then it'll be
It's x, y cubed.
log b x cubed times y cubed. You would not get that. Okay? So after you have this and you want to condense it, it's just log b x cubed times y cubed. All right? This one is true because if this comes down, then you have 5. Okay, so this one is true. So when that one comes down, then you have 5 log bx plus log by, and you can put it back up.
What would we write for 21 for false with the constitution?
Actually,
3 log of px plus 3 log
okay,
of
it's time. And then this one is true. Try this one out. So I have solutions of these online as well, okay?